In part C of this problem, you're asked for the most and least amount of gravel in the plant during the 8 hours. And so this in the plant is critical because that means we're going to have 1,000 because that's what we start with. And then we're going to integrate this rate gt from 0 to any time x. But we also need to subtract off the 15t because that's how much we are removing. Again, we've got some going in, but also some going out, and both need to be considered. This is going to be the amount, if you will, at any time. So we'll say amount of t is equal to that function. Well, we know that our max and our min will be when this derivative, or this a prime, is equal to 0. So we really need to take the derivative of this entire quantity with respect to t. When I take the derivative of this 1,000, of course that's 0. When I take the derivative of this integral, then I have the derivative of the integral cancels out, and I really just have g of t minus 15t equaling 0. So whenever this is going to happen, whenever these two rates combined equal 0, will be our critical points. Those will be candidates for relative max and mins. So we could have our absolute max at any of these locations, but they could also be at t equals 0. And we're not going to use 8 hours here, we're going to use 7 because we know that this is only good from 0 to 7. So t equals 0 is a candidate, and also t equals 7. So we've got to somehow solve this equation. When does 0 equal gt minus 15t? And the easiest way to do that is just using these expensive graphing calculators that we've got. I'll graph y1 as 0 and y2 as this function you see here, and you should do the same. When you graph this on your calculator, you'll see something that looks like this, where this is 7 and this is 0. So we've got to find what are the times for these interior critical points. And since I've graphed two equations, y1 and y2, I'm going to find the intersection of 0 and this other function. So the first intersection is 3.628 hours, and the next one is 6.220 hours. So those are our candidates for our absolute max and min, and of course our endpoints, 0 and 7. One of the best ways to decide where we have an absolute max and an absolute min is to create a little table with our endpoints, 0 and 7 for times, and those two interior critical points that we just found. So this first one, we only have 1,000 tons of gravel in the plant at time 0. The next, all of the rest, are going to be the same formula from 0 to whatever this time is. And we know each of these times. This first time is 3.628 gt minus 15t dt. Our first amount turns out to be 1179.132. And I can just keep that same integral in there and change the upper limit each time. So these are the three calculated values for our different times, two interior critical points and an endpoint. As you can see, 1,000, that's going to be our absolute minimum, and 1179.132, this will be our absolute maximum. So that's what we should report as our answers. And with this table, and it's key that we've shown where the rate in minus the rate out equals 0, so we found our interior critical points. This is anything that's going to be critical on one of these challenging AP problems.